Had a request to run this little tutorial on electrical systems. This is basically an overview of a typical piston engine light single airplane or helicopter. I know it's got an airplane symbol there, but much the same in a Robinson or a Cessna or anything like that. You have the battery up the top here indicating the current capacity of the battery. It says at the moment amp hours remaining 8, because batteries are rated in amp hours. If we turn the battery switch on, we can actually see the voltage of this battery is 22.1 volts here on the voltmeter. So it's presumably a 24-volt battery, but it will normally run at about 28 volts when the alternator is charging it. At the moment, it's only sitting at about 22. That's sort of its resting charge at about mid capacity there. The engine's not running, but the avionics are off, but the main bus is on here, indicating green. And there's not much load because nothing's really switched on. But if I turn things on, like a landing light or pitot heat, we'll see more and more discharge from the battery on the the center zero ammeter up on the top here. This one is center zero. There's also a left zero ammeter down the bottom here, which is alternator output, which is 0 at the moment because the engine's not running. But the more things I switch on, the greater the negative discharge on the center zero ammeter, indicating battery capacity is being discharged with no charge going back in from the alternator because the engine's not running. So at the moment, you can see that battery capacity is dropping rapidly. It's down from 8 amp hours to 7.6 amp hours, 7.5. So that battery is rapidly depleting because we're running all of these services without the engine running. So that would be a little bit silly. So we turn a few things off. There's a little bit of a discharge now on the center zero ammeter because a few things can't be turned off, like engine instruments and the cooling fan and the fuel gauges. I mean, I can pull that circuit breaker and that will stop that. But even still, the turn coordinator is running. I can stop that. And that pretty much now means that there's no power going anywhere. So there's zero indication on the center zero ammeter. So the battery is not being depleted, but it's not being charged, and there's really no electrical power flowing anywhere. If I put those circuit breakers back in, those little things we really can't turn off just tend to put a small drain on the battery. So if we wanted to start the engine, I would need to turn on the master, which is a 2-part switch. The battery switch is part of the master, so we turn it on. But the other part of the master is also the alternator switch, which we can also turn on, which then provides a little bit of current to the alternator's electromagnet. If I turn that alternator field switch off again, you can see the alternator's magnet becomes demagnetized because the alternator doesn't have its own magnet. It's only got an electromagnet. And unless you have that electromagnet powered from the battery, even starting the engine and turning the alternator is not enough to cause the alternator to put out electrical power. So the alternator switch is half of the master and the battery switch is the other half of the master. They're normally both next to each other and you press both of those switches together. The big red double rocker master switch does both of those jobs usually. Then I can turn on the magnetos in preparation to start the engine. And with the battery switch on, the alternator switch on, the magnetos on, all I need to do is turn the key, which is the starter switch here, engage the starter motor relay, starter draws 300 amps, and off we go. And the engine is now started, and immediately the load meter on the ammeter shows somewhere between 0 and 25, probably about 10 or so amps, and positive on the center zero ammeter, initially high positive and then drifting back towards 0 as that battery is topped back up. And you can see it's already back up to 10, 10.6, 10.7, 10.8, 10.9. So that battery is really rapidly being recharged, and the voltmeter is showing 28, which is the standard network voltage, but you won't see that full 28 volts unless the alternator is actually pumping out some power, because the battery doesn't really manage to preserve the full 28. you're running off battery only, it'll be somewhere under 28, sort of between 22 and 26 normally, depending on the state of the battery. So if I was to turn the alternator switch off, immediately the load meter drops to 0 because that's what a load meter indicates, alternator output. And without the alternator switch on and without the electromagnet providing magnetism or the coils of the alternator's field, it can't produce electricity. The engine's still turning, the alternator's still rotating. But without any energy going to the electromagnet of the alternator, it cannot produce output. So you've got to put power in to an alternator to get power out of an alternator, even though it's rotating. So the engine's still providing horsepower to the alternator, but it's not producing electricity. So we've got drain on the battery. Not much because we haven't switched much on, but if I put on a large load and turn on pitot heat and turn on lights, turn on weather radar and all that sort of thing, we've got a large discharge from the battery, rapidly depleting the battery, but nothing out of the alternator until I switch the alternator's field on. And then all of a sudden, the alternator goes to nearly 50 amps because that's about the draw of all of the services and a small positive charge to the battery with what's left over as well. So now the alternator is supporting all of the loads of the aircraft electrical system and a little bit left over to top up the battery as well. But turn things off, you can see then the load drops quite dramatically and still a little bit of residual. The battery is virtually full now, 15 amp hours. It's basically a full battery. So the battery is fully charged. The alternator is drawing 0.9 of an amp, but is putting out about 10 amps. So we're only putting in a tiny little bit of current, maybe less than an amp, to run that electromagnet, that green ring around the alternator, to get 10 amps worth of alternator output. And as long as the alternator switch is on, as long as the alternator field is magnetized, and as long as the engine is turning, you will get electricity from the alternator. And the left 0 load meter shows alternator output, whereas the center 0 ammeter just shows battery current to or from, and a positive indication on the center 0 ammeter is charge to the battery, which is a very small positive deflection at the moment, but the battery is almost fully charged. And as I turn things on, alternator load increases and current to the field increases. So now running all of these things, the light, the pitot heat, I turn on the radios, well, we're pulling nearly the full 50 amps, and I'm sending 4.5 amps to the alternator field. But 4.5 amps in to get 50 amps out is a pretty good deal because you're producing a stronger magnetic field. Now in the alternator, it would take more horsepower to turn the alternator. The engine would be under greater load on the alternator belt to run that alternator with a stronger magnetic field. But we're putting 4.5 amps in to get 50 nearly out, 45 amps out, so nearly 10 times. And that's how an alternator works. It can't produce electricity without its field. As soon as I turn off the alternator field, boom, alternator output drops to 0, battery massively discharging because now the battery is the only source of power. And the battery is just being drained rapidly to support the load. Then the voltage dropped straight to 24 volts. We're not getting 28 anymore. We really only see 28 volts with either a completely topped up battery with no load or when the alternator's running. But as soon as I put the alternator back on, system voltage returns to 28, a little bit of a positive charge, indicating charge to the battery, and a significant load on the load meter because the alternator is working very hard to produce nearly 50 amps of current to run all of these things. But as I turn things off, radio master switch off, drops to maybe 25, 26 amps. If I turn off the pitot heat, drops below 25 amps. Turn off the landing light, drops to maybe 10 amps. And that 10 amps is really just the total of the few bits and pieces that I can't really switch off. There's a 5 amp load on the turn coordinator that's consistent. There is a little bit of load on the engine instruments and the cooling fan and fuel gauges. I can't really turn them off because they're pretty much hardwired to the battery the whole time. There's a little bit of load going to the alternator field, only 0.9 of an amp. So those are really what's adding up to this 10 amp load when we're really not running too much. And if I was to turn the engine off by turning the mags off, neither the engine stops. So the alternator, even though it's powered, is no longer producing output because I've got the magnet magnetized, but now it's not turning. So for the alternator to be able to produce current, two things need to happen. The engine needs to be turning the alternator, and the alternator's magnet has to be powered because it's an electromagnet. So if you've only got one of those, either power to the magnet or alternator turning, that's not enough. It needs to be both power to the magnet and alternator turning for you to be able to get alternator output. So at the moment, we're just relying on battery support. So the battery is showing negative on the center zero ammeter, meaning the battery is just gradually depleting, and the voltage has dropped to 24 volts, which is about the charged voltage of a fully charged 24 volt lead acid battery. Hopefully that helps.